One of the substantial critiques of the Baron and Kenny method is that there's no way to falsify the null hypothesis that the indirect effect is zero. So note that we went through the Baron and Kenny method, but there was no way to really know how much drop in that C-path would be enough to indicate that the indirect effect is significant. And recall that the indirect effect that we found was very, very small in value. It was about 0.006, and so depending on the scale of the DV, that could be really not that significant a finding, or it might be, but we don't know, is the point. And so the Sobel test is one way to find out if your indirect effect is significantly different from zero. And it's a z distribution, and the test statistic itself has the A times B path, or the indirect effect, in the numerator, and then it's divided by the standard error of the indirect effect. So this has been used more or less in the past, but it is not recommended currently for most mediation tests because the bootstrapping method is so much better and more accurate. And so the Sobel test has kind of fallen by the wayside, except for special cases where we are doing a two-experiment design where we are manipulating the IV to notice its effect on the mediator, and then in turn we use a new sample and manipulate the mediator to notice its impact on the DV. That's a two-experimental design in order to strengthen the causal inferences from mediation that we can draw. I'll talk more about that later, but if you're doing that kind of test, then you need some kind of way to test the indirect effect, because bootstrapping won't work because you have two different samples. So anyway, Sobel test can be used under special conditions like that, and it can be found like calculators. I think Preacher has one actually, and he on his website, and you can go on his website and enter some of the pieces of data from your study, and it will calculate the Sobel test for you, and then you can see if your indirect effect is significant. So just a quick overview of the bootstrap technique, or review actually, because I think I mentioned it before in this class, but what bootstrapping does is the computer creates a huge population from your data set that has the same parameters, so the population parameters like mu and sigma, as your original sample. Okay, so the same mean and variability. And it uses this like a big pool of units to sample from. And so then it samples thousands of times with replacement, however many thousands you tell it to do, like 5,000 we did before. And it samples, and the sample sizes are the size of your original sample. So it's your n size of your sample, that's the n size of the samples that it pulls with replacement. And what it does is it computes the indirect effect from all of those samples, and then it takes the average and the variance of those indirect effects and creates CIs around the estimate. So let's say 95% of the bootstrap samples fell within a certain range. That would be your CI for that. And if the range contains 0, then we know that the indirect effect is not significant. I mean, within the 5% error, of course. If that range does not contain 0, then we would say that the indirect effect is significant at p.05 or whatever we have specified. So again, the n size is the size of your original sample. So in this case, we have a sample size of 62, recall, with our self-fulfilling prophecy study. And we're going to pull 5,000 samples of 62, and we let the computer process and the software calculate the mean and standard deviation of those indirect effects that it has pulled from all those samples. And then it's going to construct CIs for us around the estimates. Okay, so we've learned about the Baron and Kenny method, and we've learned about the Sobel test, and now we're going to get into process, which is what everyone's using to test mediation. So this is really exciting. So I'm going to do a screencast for that in the next segment.